Hello everyone, this is Purvima, Assistant Professor in the Department of ECU at SNS College of Technology, Coimbatore. So in this playlist, we are going to study about the course Analog Communication. The topic that today we are going to discuss is Amplitude Modulation. So, okay, amplitude modulation. What do you mean by modulation means? So, why we need modulation first? Since our message signal is a low frequency signal, so such low frequency signals cannot reach the long distance receiver. So, we need a medium to transmit our low frequency message to the long distance receiver. That is nothing but a carrier signal. So, in this amplitude modulation, according to the amplitude of the modulating signal, the amplitude of the carrier signal is varied. So this is called as amplitude modulation. So in this graph, you can see it is an amplitude modulated wave, that is output of the modulator. So here you can see it has a high frequency, and the amplitude of this wave follows the envelope of the input modulating signal. Next, we'll discuss about how the block diagram works in the amplitude modulation. So first, the inputs to the modulator is one is modulating signal, nothing but a message signal. And the next one is carrier signal, which is high frequency signal. This is going to get modulated according to the modulating signal amplitude, and the result is called as modulated signal. We'll see the representation of amplitude modulated graphs. First signal shows a carrier wave. Since it has high frequency, so we can consider this as our carrier wave. And the next wave is nothing but it's a low frequency message signal called modulating signal. And in this third graph, you can see the carrier wave, amplitude of the carrier wave is varied according to the amplitude portion of the modulating signal. So it is nothing like the modulating amplitude of the modulating wave is overlapped on the carrier wave. So on the result, you can see it is an amplitude modulated. The fourth graph is nothing but amplitude modulated signal. Here you can see it has frequencies very high, and the amplitude is nothing but just envelope of the modulating signal. And the next, so we'll see how we can analyze AM wave in time domain manner. The first wave, first equation represents the modulating low frequency signal. So nothing but M of t, that is AM cos omega mt. AM is the amplitude portion, and omega m its frequency. It's a cosine wave. And likewise, and the next one is carrier signal C of t, AC cos omega ct. So AC it's amplitude, omega c it's a frequency. So omega c is a high frequency where omega m is a low frequency. And the result is AM modulated signal. Since we discussed amplitude of the carrier is varied according to the message signal. So AC is varied according to the M of t. Therefore, AC plus M of t into cos omega ct. So we are not going to do anything with the frequency of the carrier. So we just keeping cos omega ct as it is, only the AC is modulated according to the M of t. So therefore, amplitude modulated signal equation will be like AC plus M of t into cos omega ct. And after doing mathematical steps, and the resultant AM modulated signal will be like the equation contains three components. The first one is AC cos omega ct is nothing but our carrier signal, and the next is cos omega c plus omega m. So this is nothing but upper side of the AM modulated signal, and the next one is cos omega c minus omega m. It's a lower band. So it contains three components: upper side band, lower side band, and the carrier signal. And the next is modulation index. So first we'll see what is modulation index. So modulation index is nothing but how depth the carrier is modulated is called as modulation index. So this we can represent in two formulas. The first one is mu, amplitude modulation index is represented as mu. Mu is equal to AM by AC. AM is nothing but amplitude of the message signal. AC is amplitude of the carrier signal. In another way, we can represent this by using amplitude modulated wave. Okay, so that is nothing but mu is equal to the maximum amplitude of the AM modulated signal, that is A max minus the minimum amplitude of AM modulated signal, A min, divided by A max plus A min. So these two, using these two, we can calculate the modulation index of AM, any AM modulated signal. And we'll see the different types based on modulation index mu value. It has three categories. The first one is under modulation, mu lesser than 1, called as its weak modulation. And perfect modulation, mu will be 1. For over modulation, mu is greater than 1. We'll see one by one. The first one is under modulation. In this case, amplitude of the carrier signal is greater, much more greater than amplitude of the message signal. So therefore, it results modulation index is lesser than 1. So due to mu lesser than 1, there is an unused carrier power. So due to this, the power efficiency AM is low. So because when mu is lesser than 1, the power efficiency of AM will be low. And the next is a perfect modulation. In this category, amplitude of the carrier will be equal to the amplitude of the message signal, making mu is equal to 1. So under mu is equal to 1, there is no unused carrier portions. So this will improve the power efficiency of AM signal. And the next one is over modulation. So here AC, amplitude of the carrier is very, very lesser than amplitude of the message. So it makes mu is greater than 1. So in this category, AM wave get collapsed by overlapping portions. So this will be resulting in corrupted communication. So in practice, mu greater than 1 will not be useful. So let us see advantages and disadvantages AM wave. So its generation and demodulation is very easy in the case of advantage, and it is also useful for broadcasting and long distance communication. And we'll see its disadvantage, since the amplitude of the carrier is modulated, so it can easily get affected by the noise. And also we see under mu lesser than 1 case, there is an unused portions of carrier. This makes the power efficiency of AM wave very low. And since it has 2 FM bandwidth, making the bandwidth efficiency of AM wave is very low. And due to amplitude modulation, it gives a poor audio quality and fading and distortion issues. So these are the disadvantages of AM signal. Thank you.